Good morning. Today we are going to talk about discrete random variables. We'll start chapter 6. Our idea is to talk about discrete random variable followed by normal distribution and some application of normal distributions. So we will introduce in our class today what are random variables. We will explain what a discrete probability distribution is and construct probability distribution tables and graphs. Calculate the mean, variance, and standard deviation of discrete random variable. So let's start with the definition of discrete random variable. A random variable is a variable that takes on quantitative values representing the results of a probability experiment. And thus, its values are determined by chance. We denote random variables using capital letters such as X, Y, or Z. Discrete random variables can take either a finite or a countable number of values. Since these values may be written as a list of numbers, each value can be graphed as a separate point on a number line with space between each point. Let me pause for a second and try to give you an example to elaborate the concept of a discrete random variable. First and foremost, I should be a random variable. So we will be starting to think about experiments where the outcomes are numeric. So think about the experiment of tossing a coin. You have a fair coin and you are tossing it. In this situation, the outcomes are either obtaining a head or a tail. None of them are numbers. These outcomes are not numbers, so I will not be associate a random variable with this experiment. Whereas if I think about throwing the dice, so if you have rolled a fair six-sided dice, then the outcomes are numbers. Either you will see the face that has 1 or 2 or 3 or 4 or 5 or 6. In this situation, I can associate a random variable x, say. So this is our random variable. And I would say this random variable is going to take the values of 1, 2, 3, 4, 5, or 6. So the essential idea of understanding and interpreting a random variable is trying to think of an experiment that has numeric outcomes. Then for each of these possible values of the random variable, we are going to associate a certain probability, and we will call it by probability of x. Remember, the probability of getting 1 when you roll a fair six-sided dice is 1/6. So I will say the random variable value 1 is associated with its probability 1/6. Similarly, the random variable 2, as the probability doesn't change, it's still going to be associated with 1/6. And as you can imagine, all the probabilities, fortunately, for this random variable will be associated with the numeric value of 1/6. This table where you write the random variable on the left and you write the value of the probability associated with the random variable on the right is called a probability distribution table. Our objective is to study how to create probability distribution table. What are the necessity for mathematical purposes of having a probability distribution table? What is the mean for a random variable? What is the concept of the standard deviation of a random variable? And then use all of them in order to solve practical problem from our everyday life. So let's get back to our lecture notes. It is defining the probability distribution of a discrete random variable, which will provide all possible values that the random variable can assume together with the probability associated with each value. The probability distribution can take the form of a table, graph, or formula. Probability distributions describe populations, not samples. The two essential rules for a discrete probability distribution is as probability of each of the values for the random variable must be between 0 and 1, just like probability of an event. It cannot cross the value 1 or the value 0. It can be 0 or it can be 1, but it cannot be less than 0 or cannot be greater than 1. The other very important property for the axiom of discrete probability distribution is the sum of all the probabilities for each of the values of the random variable is going to be 1. So if you add all the probabilities that you obtain for each different value of the random variable, then the sum must be equal to 1. So as long as these two properties, property 1 and property 2, are satisfied for a random variable, I will say the random variable has an authentic probability distribution. So let's start working on a couple of problems. Use the given information to construct a probability distribution table. Chelsea is looking for a roommate and would prefer a roommate who had either 1 or 2 pets. Of the 10 possible roommates who answered Chelsea's ad, 5 have no pets, 3 have 1 pet, 1 has 2 pets, and 1 has 3 pets. With this given information, we will try to answer a couple of questions. What are our questions? First and foremost, we have to assign a random variable. Then we will find out the values of the random variable. Then we will associate each value with a probability, which will help us get the probability distribution table. So what do you think is going to be the random variable in this situation? After Chelsea has posted the ad for a possible roommate, people answered with their number of pets. So we will say the random variable in this problem is associated with number of pets. Let's try to draw the probability distribution table. As I have said, I will first get the left-hand column and I will write down the possible values for this random variable. Let's look at the problem one more time. The people that had responded to Chelsea's ad, 5 had no pets. So the number of pets for these 5 people is 0. That's your first possible outcome, 0. 3 have 1 pet, so I will say the second possible random variable value is 1. 1 has 2 pets, so that is going to be your third possible value for the random variable. And the last one has 3 pets, so this is one other possible value for the random variable. Now, how do I determine the corresponding probability values? Well, you think about how many people responded to Chelsea's ad. As the problem said, there are 10 possible respondents. Then out of these 10 people, how many said they have no pets? Well, 5. So the probability for the random variable value, 0 pets, is 5 out of 10, which is 1/2. For 1 pet, 3 people said that they have 1 pet, so it will be 3 out of 10. 2 pets, only 1 respondent said, so 1 out of 10. And 3 pets, that's also 1 out of 10. So this looks like a very nice probability distribution table. The last thing is to check this is indeed an authentic probability distribution table. How do you do that? Remember the 2 axioms you have to satisfy. Each of the random variable values probability should be between 0 and 1. How do you write it? You say probability random variable x when it is equal to the value 0 is equal to 1/2. And see, this value is clearly between 0 and 1. So we're good. How about the other? Probability random variable being equal to 1 is equal to 3/10. So again, I am between 0 and 1. Probability of the random variable value being equal to 2 is equal to 1/10. I am between 0 and 1. And probability of the random variable value being equal to 3 is also 1/10, and that's between 0 and 1 as well. So the first axiom has been satisfied. The second axiom tells me if I add all these probability values, I must get 1. So let's try to do that. And I will just remind you, I know that probability of x equal to 0 is 1/2, but when I'm adding, I'm going to use 5/10 instead, which will help me find the common denominator faster. So let's add all these values. I have 5/10 plus 3/10 plus 1/10 plus 1/10 as the 4 different probability values. And when I add them, I get 10/10, which is exactly equal to 1. At this point, I have checked both axioms of probability is satisfied. Hence, the random variable, which refers to the number of pets from the prospective roommate choices for Chelsea, is indeed giving me an authentic probability distribution. So let's build up on this concept a little bit more. So as you can imagine, our first target now is to understand what is the mean of a random variable and what does it mean to be the mean of a random variable. The working formula to find the mean of a random variable, especially when it is discrete, is to multiply each value of the random variable by its corresponding probability. So x is the value of the random variable. You're going to multiply that by the probability of the random variable. So row-wise in your probability distribution table, multiply values and then add them all. What you get is called the mean of the probability random variable. For a random variable, the mean is generally referred as the expected value. So instead of calling it mu, we will oftentimes use the notation E for expectation. So what is E? If I give you a random variable and tell you find Ex, in your mind you are thinking about finding the mean of the random variable, which is mu, and that is exactly equal to the sum of the row-wise product of the random variable value with their corresponding probability values. As simple as that. What it means to be the mean of the random variable value. In a long run, for example, if instead of responding to only 10 respondents, Chelsea had kept doing the study of people as prospective roommate choices for a longer period of time. Theoretically, we say that the study should be done for infinitely long amount of time, which is in our practical life is impossible. So we will say, if Chelsea had done this study for a long period of time, the expected value of the random variable refers to the most possible outcome for the number of pets. So in future problems, when I'm going to interpret the expectation, this long run behavior of the random variable will be a little clearer, and we will understand in context what the mean of the random variable or the expectation of random variable means in practice. The other two concepts are standard deviation and variance, and these are not very popular concepts when it comes to a random variable. In higher mathematical studies, they will mean a lot, but for us, we will learn what are standard deviation and what are variance for a random variable. We will also learn how to compute them, but we are not going to talk about the interpretation of these two values. The variance of the random variable is given by the theoretical formula of the random variable value minus the mean being squared multiplied by the probability of the random variable value. So pick one random variable value, subtract the mean from it, square the entire quantity, multiply by the corresponding probability of the random variable value, and then add them all. That will be the variance or sigma square for the random variable. As usual, the standard deviation is just the square root of that quantity. But in practice, when you compute the standard deviation or the variance, you use a different formula. And the computational formula, or in practice usage formula, it is multiplying the square of the random variable value by the corresponding probability value. So each row square the random variable value and multiply by the corresponding probability. Then add them all up. These products, add them all up and subtract the square of the expectation or the mean. That is going to give you the variance. If you take the square root of the variance, you get the standard deviation. As usual, we are not going to even try to remember these formulas. We're going to use Excel spreadsheet to work it out. The Excel spreadsheet that we will be using for this type of problem is posted on shared class file under your course. So if I go to Excel spreadsheets, there is a spreadsheet that is called the sampling distribution mean and standard deviation. And I'm going to write it down, which Excel spreadsheet you're going to use to find the mean and standard deviation for random variables. But let me first talk about what you need to remember. The spreadsheet is going to look like this. Your objective is to just fill in information on the first column. So you will start with row number 2. If you have a random variable value, you delete this X there, put the random variable value, and then write the corresponding probability value on column B. That's all we need to do. Put as many as you want. And I will show you in the next problem how to use this table. But do not erase the rest of the X's from this table. The X's are there for a successful completion of the run of the Excel spreadsheet. So the Excel spreadsheet that I said we're going to use is called sampling distribution mean and variance. So it is in shared class file under the folder Excel spreadsheet. You just have to click on sampling distribution mean and standard deviation. So let's write it down so that we remember for future usage. Now let's start talking about this problem. This is about teenage smokers. The National Survey of Drug Use and Health in 2005 reported that 5 million young people aged 12 to 18 had tried tobacco products in the previous month. The table contains the proportions of 5 million who had done so at each age level. Let X be the random variable that refers to the age of the person who had tried tobacco products in the previous month. So this table is basically the random variable X referring to age and its probability distribution table. Construct the probability distribution graph for X. This one we will answer simply using Excel spreadsheet. And I'm going to show you the work for doing that. You're going to get two columns. So open a new Excel spreadsheet, and then on two columns you are going to get the values for the different ages that were suggested in this problem. So let me type in those ages. The first column is 12, 13, 14, 15, 16, 17, and 18. These are the different ages that we have. And then I'm going to fill in the information for the probabilities. 0.01, 0.04, 0.07, 0.13, 0.18,
0.23, and finally 0.34. Once I have input all that information, I'm going to select both of the columns altogether. Then I will click on Insert, and it will show me all types of possibilities that you can use to graph statistical data. Since I want a bar graph, I will select one of these and see if I click on this thing, it's going to show me the age group between 12 and 16 and the age group between 16 and 20. This one shows you the Pareto chart. So if you go ahead and try the other graphs, for example, see the recommended graphs is one option that you can always try, but what I prefer, I always go ahead and pick the simple bar graphs. For example, I can choose this one, and it basically talks about the different age groups, as you can see, and versus it talks about the probabilities for each of these age groups. The age groups are given in blue and the different probabilities are given in orange. We can also try doing histograms. I'm just trying to show you all type of possibilities of the charts. So let's see. This is the bar graph, and I can pick any one of them. For example, if I decide to choose this one, and I will click OK, and that clearly tells you what are the probability versus the random variable value distribution is going to look like. See, the 18-year age group has a probability 0.34, and the 17-year age group has a probability of 0.23. So let's just stick with this type of graph. So all I did, I went and clicked on Insert, and then when I clicked on Insert, it has showed me different options of getting bar graph. I went to simple column charts, and it has given me all possible ideas about how to draw a graph. And as I said, you can change your option as you like to represent your bar graphs, and I will leave it on you, and let's carry on. So this is what I am expecting when I say, given a probability distribution, you will construct the probability distribution graph for X. Let me do one other thing. Let me just copy this bar area and paste it on our lecture note. And wow, let's do it. All right, so as you can imagine, we already have the construction of the probability distribution graph for the random variable X. So let's carry on. The second problem is asking me to find the probability that the random variable will be less than 16. What does it mean in practice? It is the probability that someone is going to use tobacco products who is under the age group of 16. So under the age group of 16 is going to be age groups 12, 13, 14, and 15. So when I'm answering this question, I'm going to first go ahead and write it as probability of X less than 16 is equal to probability of X exactly equal to 12 plus probability of X exactly equal to 13 plus probability of X exactly equal to 14 plus probability of X exactly equal to 15. Now each of them, you have probability values given to you, and the probabilities are 0.1, 0.04, 0.07, and 0.13. So we are going to write these probability values, and that will help us add them, and then we can get the required probability. So let's try to work this problem out. As we have found all possible probability values for the first four age group, 0.01, 0.04, 0.07, and 0.13. So we'll get equal to 0.01 plus 0.04 plus 0.07 plus 0.13. Then I'm going to add them. So as you can imagine, this is going to add up to 0.25, and that's the required probability. What if I'm trying to compute the probability of x less than equal to 16? So this time, not only I will have everything that I had in the last problem, on top of that, I will have the probability of x equal to 16. So I can say that this is probability x less equal to 16, which is probability of x less than 16 plus probability of x equal to 16. Or if you want, you can actually go ahead and write down this is equal to probability of x equal to 12 plus probability of x equal to 13 plus probability of x equal to 14 plus probability of x equal to 15 plus probability of x equal to 16. Either way. And eventually what you can think right now is the first one, if I compute the probability, I already have the first four, so 0.25. I'm just going to add the probability of x equal to 16 with that. And I know that that probability is 0.18. So let's go ahead and I will say this is 0.18 and this is going to be 0.43. If I wanted to compute it by computing all 5 of the different age groups, then I just have to do the sum one more time. I will say it's 0.1 plus 0.01, 0.04 plus 0.07 plus 0.13 plus 0.18, which will still add up to 0.43, whichever way you like it. What is the difference between your answers to part B and part C? So it is clearly obvious. The difference is the probability at the age group of 16. So I will say the probability of the age group at x equal to 16. Identify the most likely and the least likely values of x. And you can imagine I will just look at the probability distribution table. So I will answer for the age group. So I will say the most likely one is the one with the maximum probability. So the most likely and the least likely is with the least probability. So let's check them. So the most likely age group to smoke is the 18-year-olds and the least likely are the 12-year-olds. So answer that question. Most likely is 18 years. Least likely is 12 years. Pretty simple. Calculate and interpret the expected value of the variable age. So now we are going to calculate and interpret the expectation. So calculation is pretty simple. We're just going to use the Excel spreadsheet. And I'm going to input these information. So let's go ahead to the Excel spreadsheet and we are going to input all information there. So let's see. Remember what I told you about inputting information. First, you will start with row 2 in column A and put the random variable values. So 12, 13, 14, 15, 16, 17, and 18. And see, I will leave the rest of the rows with the x's. It is necessary that you do not erase these x's. The only other information that you're going to put in are the probabilities. So I will say 0.01, 0.04, 0.07, 0.13, 0.18. And then I remember there were 2 more information, 0.23 and 0.34. 0.23, 0.24. And the table is auto-populated. And if I maximize and scroll down, it's going to show me everything. See, I used EX, that's the expectation or the mean. And then I have S squared and the S values. So the only other thing I will make sure that I have done right, I think I did this probability wrong. That should be 0.34. Let me check it. Yes, 0.23 and then 0.34. So we have 16.48 as the mean value. And remember, the mean value is the mean random variable value. That will help you interpret the information. So it says expected value. I will clearly write down expectation of the random variable is 16.48 that I got from the spreadsheet. How do I interpret this thing? Remember, this is long run. So we'll say if this study about teenage smokers, I'm saying smokers, but this is anyone who has used tobacco products, about teenage smokers had been carried out for a longer period of time. Remember what I told you. Theoretically, this is infinitely long time, but theoretically and practically are different. So we will just go with the word for a longer period of time. If you have done this study for a long time, the most likely age group to use tobacco products will be between 16 years old and 17 years old. So that is the interpretation of the expectation value. The next question is asking us, calculate the variance and the standard deviation of the variable age. So you're going to use sigma square, even though the spreadsheet is saying S square for the variance and sigma for the standard deviation. So S square is sigma square, standard deviation square or variance. And our spreadsheet tells us that that value is 2.2896. So we're going to write it down, 2.2896. Sigma is the square root of this number. I don't have to do it because the spreadsheet has calculated this value for me too. So it's 1.513142. 1.513142 answers my question. Determine whether a 12-year-old who had tried tobacco products in the previous month would be considered unusual. How about a 13-year-old? So when you read this word unusual, you are actually thinking about the empirical rule of understanding moderately unusual, unusual, outlier using the z-score method. So what I'm going to do, I'm going to find z-score for 12 years old. Remember the formula? It is the raw data, so 12 years, minus the mean data, which we found out to be 16.48, over the standard deviation, and that is 1.513142. So this is what I'm going to find out. And that will be the z-score for 12 years old. So let's go to our calculator and try to find this number. So as we said, 12 minus 16.48 is going to give me negative 4.48. So now negative 4.48 will be divided by the standard deviation, which is 1.513142. And I get negative 2.96. So I will say that this is around negative 2.96. Now let me remind you what we have talked about: moderately unusual, usual, and outliers. If you are between the z-scores of negative 2 and 2, then you are usual. If you are between negative 2 and negative 3, you are moderately unusual. And between 2 and 3 is also moderately unusual. And if you are more than 3, so this area is outlier. And similarly, less than negative 3 is outlier.
So we wanted to know, are these data unusual? And we found the z-score is negative 2.96, which is somewhere near, very close, near to negative 3. So clearly, we will say yes, that will be unusual. 12-year-old using tobacco product is moderately unusual. So it will be moderately unusual. And then it said, well, how about 13-year-olds? So I'm going to pretty much repeat the same work. I'll find the z-score for 13, which will be 13 minus 16.48 all over 1.513142. So let's calculate this number. I will go to my calculator and pretty much repeat the same work. 13 minus 16.48 will give me negative 3.48. So now you have negative 3.48 and you divide by 1.513142. And your value is around negative 2.3, rounded to 2 decimal places. That's negative 2.3, but still moderately unusual. This time the value is close to negative 2. As I said, it's negative 2.3, but I will still say, yes, 13-year-old using tobacco products will be also moderately unusual. And that answers my question for this probability distribution about teenage smokers. Let's go to our next set of problems on the next page. And this is going to introduce a new probability distribution for us, which is called a binomial probability distribution. A binomial probability distribution is a beautiful probability distribution, and it is very important in order to understand the probability of so many outcomes for so many experiments. Generally, the word binomial is going to refer to the experiments where the outcomes are either yes or no type. So it's going to be a binary type of outcome experiment. For example, again, think about, you tossed a coin. How many outcomes you have? 2, either heads or tails. Those are the experiment that can be associated with a random variable, which we will call the binomial random variable. Now, there are difficult formulas in order to understand the probability distribution of a binomial random variable. What we have done for our purpose in our class, we made everything very clear and easy to compute. So we're not going to worry about the formulas. We will just remember, I can associate a binomial distribution to an experiment where the outcomes are always referring to either success or failure. There are 2 ways. And when I do the problems, I will explain it way better, and you will see in context how I decide whether this is a binomial distribution problem or not. The formula for finding the probability is probability of the random variable value for a binomial distribution is n choose x, that's the combination formula, times probability of success p to the power number of successes times probability of failure 1 minus p to the power the number of failures n minus x, where n is the number of trials. So when I talked about these things, you probably are already very confused and thinking, how would I going to evaluate all these things? Well, don't forget, we're going to use Excel spreadsheet to do all the calculations for us, and we're absolutely not worrying about formulas in this class. We want to understand when we can use binomial distribution, and I will show you how simple execution of this distribution is. But what we need to remember now and so on, I will use certain notation. N is called number of trials. That means how many times the experiment has been repeated. X is called number of success. This is the desired number of success that you want in your trials. P is called probability of success. We will always assign one of the outcomes as the success, and the probability of that outcome is going to be probability of success, or P. Clearly, 1 minus P will be probability of the other outcome, and which we are going to refer to as probability failure. As usual, we will talk about the mean of a binomial distribution. The mean of the binomial distribution is pretty simple looking formula. It's mu equal to NP. The variance of a binomial distribution is given by n times the number of trial times the probability of success times probability of failure. The standard deviation is given by the square root of that quantity. Again, I absolutely do not need to remember any of these information because all of that will be calculated in probability. We will just stress on the very fact of understanding when possibly I can use binomial probability distribution in order to talk about the probability. The mode of a binomial probability distribution is the most likely outcome of the binomial experiment for the given values of np and x. That is the outcome with the largest probability. So this is exactly like the concept of mode that we have studied when we did data distribution. So let's start talking about problems. Women in management. According to the US Government Accountability Office, women hold 40% of the managerial positions in the United States. Suppose we take a random sample of 20 people in management position. So we took a random sample of 20 people. Find the probability that the sample contains exactly 10 women. How do I answer this question? Well, think about it. You have a sample of 20 people. You are asking them, are you a manager and woman, or are you a manager and a man? So if you have woman, then it's success because that's what you want to know. What is the probability that the sample contains exactly 10 women? And the failure is if the manager is a man. So we will say, yes, this can be done by a binomial distribution. Why? Because there is success, which is the manager is woman, and the failure is the manager is a man. And in general, we are not going to care about the failure. We will just use everything in terms of the success. So I will just say woman manager is our success. Now remember, what other information I need to know? I need to know what is the probability of success. Well, that is given in this problem. Women hold 40% of the managerial positions. So in probability, that's 0.4. So probability of success is 0.4. Number of trials, I need to know how much is n. Well, think about it. How many people you're going to ask this question? That many times you're going to repeat the experiment. Well, 20, because the sample size is 20. So number of trials is 20. How many success you want? You want exactly 10 women manager. So the number of success is 10. All I need to understand whether I can use binomial probability distribution. If yes, what is the probability of success? What is the number of trials? And what is the number of success? Then we will use a probability distribution spreadsheet, one other Excel spreadsheet. So if you go there, it's pretty easy to understand. And see, there are two probability distribution, one called binomial distribution and expectation, the other binomial distribution. I will go ahead and click the binomial distribution and expectation. And this is pretty self-explanatory what we are trying to do. I do not need all this information here, so what I'm going to do, I'm going to just delete it also that it doesn't confuse you. Okay, so this is what I need for the binomial probability distribution Excel spreadsheet. All I'm going to input is what are the probability values. So I found that the probability value is equal to 0.4. That should automatically change my next column for probability of failure. So this is the column that I am going to change the value. Let me just put a note there so that we don't get confused on what are the information we're trying to use. So I will say input information on this box. I have to change the number of success and the number of trials. We found that the number of trials is 20. So I will go ahead and say that input information there.
finally, we have to change the number of trials. So that I want to be 10. So we'll go ahead and say that. And input information here. So those are the only 3 boxes where you're going to input information. And that has talked about the probability. So M stands for the mean or expectation. S squared stands for the variance. S stands for the standard deviation. So it pretty much calculated everything. It has also calculated other thing which is called cumulative probability, which we will need, and when we will need it, I will talk about this at that time. But for the time being, I have my probability. I will go ahead and say that this is rounded to 4 decimal places. It's going to look like 0.1171. So how to answer this question? When the question is asked, you read it, you found all the information, and you say probability that the random variable is exactly equal to 10 is going to be 0.1171. Answers my question. The next question is asking you, find the probability that the sample contains at most 1 ohm. At most 1 ohm. What does that mean? It means you find the probability that it contains exactly 1 ohm plus find the probability that it contains no ohm. Those are the 2 situations that will come in at most 1 ohm. And I'm going to find each of these probabilities in my binomial distribution spreadsheet. So see, pretty much all the information are there. I'm just changing the number of success. So if I do 0, I get this number, which is 3.66 times 10 to the power negative 5. So this number, how do I interpret it? This minus 0.5 means you are going to have 5 decimal places after the decimal point. So clearly this data I cannot round to 4 decimal places, then I will have all zeros. So to avoid that, I will say the probability when the number of success is 0, remember what I said, negative 0.5, it means you have 5 decimal places after the decimal point. So I will go ahead and say that this number looks like, for probability of random variable being exactly equal to 0, is a 0.1234, and then I have the 3. Let me try to help you understand that one more time. Look at the value I obtained. It is 3.65616. What I need to do, I need to move this decimal point to the left till I get 5 decimal places after the decimal. When you move the decimal to the left of 3, you already counted 1. You need 4 more, so I get 4 zeros. So that's what we're going to use for the probability of x equal to 0. How about probability of x equal to 1? This time, I can round it to 4 decimal places, and I will get 0.0005. That's our probability of x equal to 1. So I get this is equal to 0.0005. And then I add them and I get 0.00053 as my final answer for the probability that the sample contains at most 1 ohm. How about the probability that the sample contains between 8 and 10 inclusive? So this time I'm asking you find probability of x equal to 8 plus probability of x equal to 9 plus probability of x equal to 10. Remember, I did the 10 situation already, and we did find the value as 0.1171. So let's do it for 8 and 9. Again, all I need to change is the number of success. So for the number of success, I'm going to put 8, and that will give me 0.1797 plus 0.1797. That should be for 8. So if I want to be precise, I will actually write it here, 1797. And then finally, I'm going to write down the probability for the number of success being 9. So one more time. I'll go ahead and say 9 for the number of success, and the probability is going to be 0.1597. 0.1597. And then you add all three of these information. So 7 plus 7 is 14, plus 1 is 15. 1 plus 9 is 10, plus 9 is 19, plus 7 is 26. 2 plus 7 is 9, plus 5 is 14, plus 1 is 15. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4. So it's 0.4565. The probability that the number of women manager will be between 8 and 10 inclusive answers your question. What else we have? This next question is talking about women in depression. According to the National Institute for Mental Health, nearly twice the proportion of women, which is 12%, as men, 6.6%, are affected by a depressive disorder each year. Suppose that the random samples of 5 women and 5 men are taken. Let X represent the number of women affected by the depressive disorder. Find and interpret the mean of X. So clearly this one I can say is a binomial distribution. Why? Because I have a sample of 5 women. I'm going to test whether these sample, each of these women in the sample are suffering from depressive disorder. If answer is yes, we're going to call it success. So depressive disorder is going to be the success. Don't get me wrong. I'm trying to help you understand what is the required probability in the problem. Let's just call it success. I don't want anyone to suffer from depressive disorder. So depressive disorder being found will be considered as the success. Then what is the probability of finding someone with depressive disorder? Well, it's 12%. Change it to probability terms, you get 0.12. How many women you are trying this data on? Well, there are only 5 of them, so sample size is 5. So first thing, we're going to find and interpret the mean of X. So what we will do, for the mean, we will go to our binomial probability distribution spreadsheet and change information accordingly. This is going to be 0.12, probability of success. Number of trials is going to be 5. And I do not worry about anything else, I just look at the mean. The mean is 0.6. So we're going to answer the question accordingly. The mean is 0.6. And I will write it as expectation of the random variable is 0.6. Then interpretation. So long run, we're going to say if the study of women in depressive disorder with 5 individuals had been carried out for a longer time, the most likely number of women suffering from it will be less than 1. So if you have the sample size of 5 women that you randomly pick and study for depressive disorder, there will be less than 1 woman suffering from depressive disorder. If possible, find the probability that X equals the mean of X. If not possible, explain why it is not possible. So now I am asking you to find probability of X is equal to the mean 0.6. I will say it is not possible. Why it is not possible? Because remember, X represents the number of success, and number of success cannot be a fraction. It cannot be a decimal number. So I will say that as X represents number of success and cannot be a fraction. It should be a whole number because my mean is 0.6, a fraction, it cannot be found. Construct the probability distribution graph of X and identify the mode of X. So now we are going to talk about the probability distribution table and hence the graph. So what I'm going to do, I'm going to find out all possible values for the random variable value of x. So recall, since you have the number of trials, or you are trying 5 different women, what are the possible numbers that you will find are affected by depressive disorder? Well, there could be 0 of them. And see, when I got 0, the probability that I found out is 0.527731917. What I will do, I will go ahead and the graph that I have created last time, I will use this information here. And I'm just going to put the value of the probability that I found out, round it to 4 decimal places. So I would say 0.5277. The other possible value is 1. I can find only one woman with depressive disorder. Probability is 0.3598. So random variable is 1, probability is 0.3598. The next one, random variable value could be 2. 2 women out of the 5 are suffering from depressive disorder. Probability is 0.0981. It can be 3 out of 5. So let's see what we get for number of success being 3. 0.0134. It can be 4 out of 5, so number of success is 4, and the probability becomes 0.0009. And the final option, you can have 5 women suffering from depressive disorder. So I will go ahead and put 5 out of 5. And see, again, I get the information which is e to the power negative 0.5. So I need 5 decimal places after the decimal point. So if I move the point to the left of 2, it counts for 1. I need 4, so put 4 more zeros. So your answer is going to be 0.402. And that's it. That's what is the probability distribution graph is going to look like. As usual, I will copy it and go to my lecture note and paste it. And we'll make it smaller looking and drag it on the answer for this question. And then it is asking me, what is the mode of this distribution? Remember, mode is the random variable value with the highest probability. Clearly it is 0. So I will say mode is the age group X, the number of patients suffering from depressive disorder, 0. Find the probability that X equals the mode of X. So we'll find probability of X equal to 0. This one can be found. We already found it. So we'll go ahead one more time. Use my binomial distribution spreadsheet and put 0 for number of success and round the answer to 4 decimal places. 0.5277 is the answer. Let's do more of these type of problems. My next question is about spinal cord injuries. The National Spinal Cord Injury Statistical Center reports that 46.9% of all spinal cord injuries are caused by vehicle crashes. Suppose that we choose 1,000 spinal cord injuries at random. Let X be the number of spinal cord injuries caused by vehicle crashes. Find the expected number of X, interpret this number. Clearly it's a binomial distribution, as we are talking about 1,000 cases of spinal cord injuries, and I'm going to consider a success when it has caused from a vehicle crash. So vehicle crash related injuries are success. Hence I can talk about the probability of success. So P, which is probability of success, is going to be 46.9%.
So change it to probability terms 0.469. Find the expected number of x, interpret the number. So I go to my spreadsheet, binomial probability distribution. I put in p equal to 0.469 and I put the number of trials to be 1,000 because that many injuries we are talking about. So if you want, I can write number of trials is 1,000. So we found out that the expectation is 469. Again, we're going to interpret this information. We will say that if 1,000 spinal cord injuries had been evaluated for possible cause for a longer period of time, it is most likely that 469 of them will be caused by vehicle crashes. That is the mean and its interpretation. Find the probability that x equals the expected value of x. So now I am asking you to find probability of x equal to the expected value, which is 469. Which can be found? You just have to change the number of success in the probability distribution table to 469. So 469 will give me the probability rounded to 4 decimal places as 0.0253. 0.0253. Then it is asking me find the standard deviation of x. It is already found. All I need to do is get that information. Standard deviation is 15.78096, but I'm rounding it to 4 decimal places, so I'll get 15.781. So standard deviation sigma is 15.781. Suppose that the sample contains 520 spinal cord injuries caused by vehicle crashes. Use the z-score method to determine whether this number is an outlier. So you are finding z 520. Remember, I should be either more than 3 or less than -3. So the raw score is 520, the mean is 469, and the standard deviation is 15.781. And I'm trying to find if this number is going to be an outlier. So let's see, the z-score. We'll go to our calculator and we will say 520 minus 469. So that is 51, and I'm going to divide this by the standard deviation in this problem, and the standard deviation is given by 15.781. So this is 3.23. So clearly this is an outlier. So we'll go ahead and say z-score is 3.23, which is greater than 3, hence it is an outlier. Then refer to the last part without performing any calculation. State whether 521 spinal cord injuries is an outlier. What is your reasoning? Clearly it is an outlier as well. So I will say clearly 521, as we found out in the last one, will also be an outlier, as 521 is even greater than 520. And 520 is already an outlier, so a number greater than 521 will be even further away from the mean, hence it is going to be clearly an outlier. Answers your question? Let's go to page number 8 and see what we have. Suppose that you randomly draw one card from a standard deck of 52 cards. After writing down which card has was drawn, you replace the card, so you put it back and draw another card. You repeat this process until you have drawn 18 cards in all. What is the probability of drawing at least 6 diamonds? Remember, at least 6 means you can have 6 diamonds, 7 diamonds, 8 diamonds, and you can have all 18 of them. So when I'm trying to find this probability, I have to execute the problem for all these numbers. This is where we will first understand that it might be that the probability is a binomial probability distribution. So let's see whether we can understand that or not. It is binomial. Why? You are choosing a card and you will do 18 of these. You will repeat this experiment 18 times. If it is a diamond, you're going to say it's a success. So I will say diamond is a success, otherwise it's a failure. Any other card is a failure. So probability of success will be what? Well, what is the chance of getting a diamond out of a pack of 52 cards? Think about it. There are 13 diamonds, so the probability of success is going to be 13 out of 52, which is 1/4, and that's 0.25. So answers my first half of the question. It is binomial with probability of success being 0.25. Number of trials is what? Because you are doing it for 18 times, it is 18. Now I want to know the probability for 6, 7, 8, and until 18. I want to know all these probabilities. So what I can do, I can run the binomial distribution for all of 6, 7, 8 till 18. Or I can find the probability of x being less than or equal to 6. I'm sorry, less than or equal to 5. So what is that going to mean? It means I have 1 diamond or no diamond, or 2 diamonds or 3 diamonds or 4 diamonds or 5 diamonds. So if I find that probability x is less equal to 5, and subtract it from the total probability 1, I get probability of x greater than 6. Let's try to understand this statement one more time. I want the probability of at least 6 diamonds. What is at least 6 diamonds? At least 6 means you can have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, any one of them. Should I find all these probabilities separately? Of course you can, but it will take you so much time. Instead, if you find the probability of the complement, that means I am 6 or up, so why don't I find 5 or less? So 0, 1, 2, 3, 4, and 5. I don't want them. So I find that and subtract it from the total. Total probability is always 1, and I get my result. I get what is the probability when x is greater than or equal to 6. So that's way easier. Now, how do I find a probability of more than one event at the same time? So what I do, I use the number of success x equal to 5. And I use the cumulative probability in the binomial probability distribution. So you use x equal to 5 as the number of success. So I'm going to change all this information. Remember, this is 0.25 probability of success. Number of trials, I need 18 of them, but I want to make sure that the number of success is 5. And I look at the cumulative probability. Round it to 4 decimal places, you get 0.7175. So I say cumulative probability is probability x less equal to 5. All of them I have calculated and added all together is whatever we got from the probability distribution table. And that number was 0.7175. And remember, this is not your answer, because now you're going to subtract this quantity from 1. So your answer is going to be 1 minus 0.7175. That is going to be 6 and up. So let's subtract this thing. 10 minus 5 is 5. 9 minus 7 is 2. 9 minus 1 is 8. 9 minus 7 is 2. So 0.7175
2825 is the required probability for the event that I will have at least 6 diamonds in my hand. And then it is telling you find the expectation and the standard deviation. Both of them should be calculated already in your probability distribution binomial spreadsheet. And the mean is 4.5 and the standard deviation is 1.8371. Answers my question. If X is a binomial random variable, compute the probabilities for the following situations. So I have given you a couple of situations and we're going to find the probability for these situations. The first one is probability of X less equal to 2. Remember, this is the cumulative one. X less equal to 2 means your X can be 0, 1 or 2. Instead of finding them all separately, I'm just going to find the cumulative one for X equal to 2. So use X equal to 2, N equal to 4 and P equal to 0.4 and see what you get. That should be your answer for the question. So let's see that. I'm going to say P is 0.4. I'm so sorry. That's not the one I wanted to work with. P is 0.4 and your N is, so in the last problem, let's see, N is 4 and X is 2. And the cumulative probability is 0.8208. Answers my first question. 0.8208. The next one is X greater than 1. So remember what we talked about. If I want X greater than 1, I rather find what is the complement. So what I say, 1 is the total probability. Why don't I find X less than or equal to 1 and subtract it from 1? Then I get X greater than 1. So I use the cumulative probability again. But what I do, I find the cumulative probability for the number of success being 1 and subtract it from the total 1. So number of trials is 8, probability of success is 0.3. So we'll change it accordingly. 0.3, number of trials is 8. And I want the cumulative probability for 1. So we first find the cumulative probability, and that is rounded to 4 decimal places is 0.2553 and subtract it from 1. So 1 minus 0.2553, which is going to be 7447. So 0.7447 is your final answer to the question. Let's see what else we have. We have 2 more. Probability of X less than 4. So if you want X less than 4, then actually you want probability of X less than equal to 3. So use the cumulative probability one more time. And this time just the cumulative probability will do it for us. With N equal to 9 and P equal to 0.8. So probability of success is 0.8. So let's go ahead. 0.8, N equal to 9. And as we have talked about, X should be number of success, which should be 3. And then I use the cumulative probability. And I get 0.0031 rounded to 4 decimal places. 0.0031. The final one is probability of X greater equal to 6. So what I do, I think about it. I can do it in 2 ways because it is saying X greater equal to 6. I can actually find probability of X less than or equal to 5 and subtract from 1. So that's the cumulative probability. And so that we understand what else we can do, you can actually do probability of X equal to 6
and probability of x equal to 7. That will do it for you as well, because there are only 7 trials either way. But let's just go ahead and do the cumulative one. So we'll use number of success equal to 5, probability of success equal to 0.6, and number of trials equal to 7. So 0.6, number of trial is 7, and x is number of success, which is 5. So the cumulative probability is 0.8414. I subtract it from 1. So I get 1 minus 0.8414. And what I get out of this thing is 6, 8, 5, 1. So 0.1586 when I subtract, and that's my answer. And that answers this question as well, which concludes our study for the discrete random variable and the spatial case of the discrete random variable called binomial probability distribution. Next time, we will start talking about continuous random variable, which is going to start exploration of the idea of normal distribution, which we're going to keep using for the rest of this semester. I will see you next time. Start working on the assigned problems, and if you have any further question, please do not hesitate to email me. I will get back to you as soon as I can.